Hello there, ladies and gentlemen. Once again, this is Lennon Elmi Tulin, your teacher for physics. So, in the past discussion, we talked about the branches of physics, the definition of physics, and its branches. And ladies and gentlemen, so in this discussion, we are going to continue, and we are going to tackle the basic quantities of physics. That's it. So basic quantities of physics, what are those units of acceleration, the force, the mass. So here in this discussion you are going to learn the basic quantities of physics. So let's start, ladies and gentlemen. So many other quantities can be derived out of the combination of the basic quantities. For instance, the speed is equals to the ratio divided by the time, and acceleration is equal to the ratio of the speed divided also by the time. And a force is the mass times the acceleration, or the mass or the kilogram times the unit for acceleration is meter per second squared. So, and it forms the um, the unit for force is Newton, right? Or the kilogram meter per second square. Next is the acceleration. So what is acceleration? So acceleration in physics is the rate of change of velocity of an object with respect to time. An object's acceleration is the net result of any and all forces acting on the objects described by Newton's second law. And what is the second law of Newton? The law of acceleration by Isaac Newton. So the SI unit for acceleration is meter per second squared, as I said earlier. So acceleration. So we have the formula for acceleration, or the average acceleration is the same. So acceleration is equals to velocity over time, or velocity divided by time, the change in velocity over the change in time. Also, the change in velocity has the formula. Change in velocity is equal to final velocity in the minus by the starting velocity. Final velocity minus the where the velocity stops, and minus the starting velocity where the velocity starts. So that is the formula for the acceleration and the change in velocity. Next is we have the electric charges. The electric charge is the physical property of matter that causes it to experience a force when placed in an electromagnetic field. So electric charges are of two general types. So what are those two general types of electric charges? So we have the positive and negative. So positive and negatives are the two general types of what? Electric charge. So two objects that have or an excess of one type of charge exert a force of repulsion in each other when relatively close together. So two objects that have excess opposite charges, one positively charged and the other negatively charged, attract each other when relatively near. And that is what we call the relative distance. So near, yet so far. So electric charge. So opposite do attracts. Am I right, ladies and gentlemen? Opposite do attracts. So this is an example of the positive energy or positive electric charge and the negative electric charge. So positive plus negative is negative, right? Am I right? Am I right? Yes. So but opposite attracts. That's it. So and now let's talk about energy. So what is energy in physics? There is a lots of definition of energy, but the definition of energy in physics is the property that must be transferred to an object in order to perform work on or to heat the object. It can be converted in form but not created or destroyed. So energy are not created nor destroyed. No. Energy is energy itself. That's the correct, the proper definition of energy in physics. Energy cannot be created and it cannot destroy. So energy comes in different forms. So we have the Many forms of energy we have. First, we have the heat or the thermal. For example, we have the fire. Fire is an example of heat. We have the light. A light is an example of the sun rays or the radiant rays coming from the sun. That is, energy comes in different forms. We have the motion or the movement of that particular matter. Move, movement or the motion or the kinetic. How the movement, how the motion starts and stops. That's the energy comes. And next we have the electrical. So electricity, of course, there is also an energy in the electricity, right, ladies and gentlemen? Yes, it is. Now we have the chemicals. Also, an example of chemicals is the amino acids. The acids is an example of chemicals, and energy comes in chemicals. So these are the forms, different forms, and nuclear energy, of course. The energy comes in different forms. So here are the forms energy comes. So, next is the gravitational energy, of course. We have the acceleration due to gravity, which is 9.8 meters per second squared. That is the formula or the amount number of gravity when it talks about gravitational energy. So, that's it. So what are the two types of energy? So there are two types of energy, and these are what? We have the stored energy and the what? Stored energy is the potential energy or the working energy or as the kinetic energy. So that's it. So for example, the food a person eats contains chemical energy. The person's body stores this energy until he or she uses it as kinetic energy during work or play. So that is an example of the types of energy. Next, we have the entropy. So what do you think entropy is? So entropy is the measure of a system's thermal energy per unit temperature that is unavailable for doing useful work. Because work is obtained from ordered molecular motion, the amount of entropy is also a measure of a molecular disorder or randomness of a system. So entropy is the measure. So entropy equals the system's thermal energy divided by the temperature that is unavailable for doing useful work. So entropy, that is the entropy. So for example, I will give you an example of entropy. What is entropy is? So a block of ice placed on a hot stove surely melts, right? Am I right, ladies and gentlemen? Of course, if you put ice to a hot stove, of course it melts, right? While the stove grows cooler, such a process is called the what? Irreversible, because no slight change will cause the melted water to turn back into ice while the stove grows hotter. Because uh, you cannot turn back to the ice, but because of the heat. In contrast, a block of ice placed in an ice water bath will either thaw a little more or freeze a little more depending on whether a small amount of heat is added to or subtracted from the system. So did you understand, ladies and gentlemen? So yeah, so entropy is called irreversible. It is no slight change will cause the melted water to turn back into ice while the stove grows hotter. So there you have it, ladies and gentlemen, and I hope you have learned from my discussion all about the basic quantities of physics. So once again, I am Len J. Almadulan, and this has been your physics adventure. Thank you so much, ladies and gentlemen, for watching and for listening to my discussion. I hope you have learned something. Thank you so much.